Fine, so let's begin with this. So what is an exception? Yeah. Or even before going into an exception, let's see a few things. Okay, fine. We have done that exercise for account class, right? Okay, and now let's try out something here from JShell, right? So JShell and minus. Okay. Yeah, you start JShell with minus class path to so that you can load classes from a particular location, right? So those can be used. So yeah, so we can now use import bang dot star maybe. Okay, and okay, we have this current account, savings account, two subclasses, and account class is abstract anyway. So let's create something like this: account AC equals new. Okay, fine. So we have this current account object created, and now let's do some deposit and withdrawal like this. AC dot. Yeah, what happens? Yeah. Let me increase one more zero here. Oh. Fine. See, what's happening is, yes, we are able to deposit a negative value and whatever we want, right? We are able to withdraw. Okay, let's withdraw. Right. We are able to withdraw that also. Oh. Yeah, I think spelling mistake there. Oh, we are able to withdraw that. Yeah, it's returning a true. But let's check what is account. Oh, it has got updated. And so one can try a deposit for a withdrawal with a negative value, and vice versa. Is this the way we had designed our account class? Do we want it this way? What should happen? It should be an error. Okay, this should have been a error. If you try a negative value for a deposit or a withdrawal, or even if someone tries something like this, okay, someone says AC equals, let me create a new current account. Okay. Okay, and let me start with a negative balance. See, all these are nothing but situations and the operations which should fail. Okay, but they are going through successfully. Right? So our idea is to fail these things. Right? Just similar to, if look at everything as an operation. See, if we try an operation which says, let's say int a equal to 75, right? And int b equal to 0. And if we say, let me see the result of a divided by b, it's giving an error, right? Okay, if I have an int array, okay, A equals, and I might have an array with some values here. Okay, fine. The array size is 4, and someone says, let me see what's the value at A of 4. That's an error. Right? Someone making AC equals null. Type is a count. Okay, and then says, let me do a AC dot deposit. That's giving an error. See, there are certain things where the operations are supposed to fail. Okay, so yes, what is an exception? Yeah. And I think we have seen the various conditions where for related to the account class, yes, what we have seen, there are no errors. Where there should be an error or there's no error there. Right? And we have just seen that yes, as far as Java is concerned, fine, the other parts of the Java are there. For example, we haven't seen this method, but let me show it. We have this method in the integer class. Okay, so if I had an int value coming from command line, fine, command line gives me only strings. Okay, then I need to convert a string into a int type. Okay, so that can be done. For example, if there is a string s is equal to 45, let's say. Okay, and then this is as a string, but I want it to be converted into a int. Right? So I can say int x equals, and then we have the integer dot parse int method, which can get it converted into a, so I can pass a string s, and that can be converted into a int. Okay, so we have a method like parse int. Okay, and then now let's change the value of s to be okay, and let's try the same thing again. Yeah, because the integer class has a static method called parse int, which takes a string as a parameter and returns an int value for it, converting a string into a int. That is done by the static method parse int in the integer class. Okay, let's try that again. And there, oh, it's an error. Fine. Number format exception for input string 4a. Okay. Fine. So yes, we have methods. When we invoke certain methods, yes, the method in the library here, the parseInt method is saying, no, you have given me a string, but that cannot be converted into a int. It's not according to the number format. Okay, the string does not contain a fine number in the required format, and therefore can't be converted to a int. Okay, fine. So we should fine. So we would like, what is it that we would like to do now related to the account class? If you think back about the account class,
you shouldn't allow a negative deposit.
Fine, a negative deposit, a negative withdrawal, a negative for the opening balance when in the constructor itself. So these are some operations which have to be failing. Right? So we have to do our checks and fail them. And so this is our target. Okay, when we should give an appropriate error, and the operation should not go through. Okay, right? Okay, so that's our requirement now, right? So now let's look into this topic of exceptions. Okay. Okay, so what is an exception? Yeah, what is an exception?
An error message?
No, not just a message. Exception is a
Okay.
some kind of an error condition. Right?
Error condition. Okay.
Okay, fine. It's an error condition. Fine. Error condition happening during a operation. Fine. Happening at runtime, you can say. Okay, so during execution there is some error condition. Okay, during execution we are carrying out various operations, right? Execution is all about carrying out some operation here and there, right? Maybe okay, so some operation can fail. Okay, fine, let's see. Okay, now as far as exception in Java is concerned, let's see from the point of view of Java. Okay, fine. See, everything is about having some kind of an object here and there, right? It's all about objects. So in Java, exception. Now I'm using the term exception here, right? Or exceptions are okay, objects of type throwable. Right? Objects of type throwable. When I say type throwable, means any subtype of this. Okay, so objects of type throwable or any subclass of throwable. Okay. In Java, exceptions are these. Okay, yeah. So what is this? Throwable is a name of a class. Okay. And this is part of the java.lang package again. Okay, so we have this class called throwable in the java.lang package. Okay. And there are various subclasses of throwable. Okay, so fine. So what is a throwable? It represents a error condition. An object which represents a error condition has information about the error which has taken place. Okay, so objects of throwable and have information okay, so any information which is useful related to the error which has occurred, okay, that's available from the object of type throwable, and it has various subtypes. Okay, and so in general, yes, throwable is the super type for all types of throwable, all type of, and throwable is nothing but a super class to represent all kinds of error conditions. Okay, fine. And how is this going to be used? Okay, fine. How do we use a throwable? Okay, so yes, we have the keyword. Okay, let's look at one thing which is related to the method, right? When we write a method, how do we write a method? Syntax for a method. Let's go back to that again. Okay, what's the syntax for a method? We have the okay, fine. So what's the syntax? We have modifiers, then
Method name.
we have the return type. Okay, and then comes the method name. Right? And then comes the parameter list, okay, which we say is the input to the method, and this is represent input to the method, right? Okay, beyond this also there are more things. There's one thing which we have used earlier, okay, when we were looking at the clone method. So this is again, I'll put this as an optional part. Okay, even the modifiers are optional. Okay, when I say modifiers, any number of modifiers may be there. Return type is a must, method name is a must, parameter list may be empty, but the brackets is a must. Okay, and then the optional part is throws, and we have a, yeah, what can be thrown? It throws, yeah, right? So here it is a list of exception types. Okay, list of the exception types. When I'm saying exception type, means subtypes of the throwable. Okay, subclasses of the throwable basically. Okay, fine. So that's a method signature. Okay, and then mainly, unless the modifier is abstract, you would have a body. Fine. Actually, there's one more modifier. I think I have not mentioned it. There's one more modifier where we do not get a body for the method. There's a modifier called native. Okay, fine. So for a method, a modifier maybe, yes, we have a native modifier also where the body is not given. In case of abstract, we understand why why we do not have a body when the method is abstract, because we are saying it's only we are only mentioning the method signature but not mentioning how it is to be done. Some subclass will override this method. It's meant for being overridden, so body is not necessary. Right? In case of declaring a method as native, the body is not necessary because the code is not written in Java. It's not that this method is not there. It has a code, but that code would be written in C or C++. You can decide that for a method, fine, I cannot write the code in Java. I should be writing it in C or C++ because I use some low-level APIs which are available to me from C language. Okay, so in that case, again, you don't give a body in the code here. You'll have to write it separately in a C file. Okay, fine. There are other related things. Fine. So that there are two cases. So let's assume. So if fine. So now coming to this method signature, yes. What do we write? We have some statements. Okay. In the method, yes, we'll have a statement, but one of the statements, fine, which you may be using, in case the return type is other than void, you will have to use it. That's a statement called we have a return. Fine, and we have a expression.
Value.
Okay, fine. Matching the
return type.
And that is important, right? It has to match the return type. The expression here has to match the return type. Okay. right? So when a method returns, what happens basically? How is this method going to be used by someone? And from some other part of the code, okay, someone is going to call and say, okay, let me use that method name, okay, and then he will pass the actual values for the parameters here, okay.
Should it be class name dot method name?
Okay, it may be some object also, or it may be a static method, or fine, depends on that. But basically, yes, this is one part of it. Okay, and you would be fine. So yes, it might be an object or the class name, fine, as a prefix on which method is called, right? So static method, then only the class name dot method name. Okay, that we understand. But we will have to have something to match the return type. Okay, so that fine, there's a whatever was the return type, same type is used, some variable to match the return for the fine, for this equal to, and then the invocation, right? Okay, fine. Okay, so what is expected here? What is expected to be done? So whenever someone uses this, that method has to, it's an operation which is performing, right? He's passing inputs through the actual values. He's passing the inputs required for doing that operation. And the return, what is it? What is the importance of return? It's giving me the result of performing the operation. Return is, I'm waiting for some result to be there. Okay, this variable, I must say, is a result, right? Okay, and it's a result. When you are right, the idea is to, the return statement is giving me a result when I perform this operation. There are some inputs which I have received, I do something and I give back a result for it. And that's how the methods have been designed, right? Okay, fine. So if this, just consider this to be something like this now. I'll match this int a equals integer dot parse int, and you're saying, okay, I see. Yeah, it was 4a, yeah, okay. Something like this. Okay, fine. And then there are more statements here. Fine. So it's, see, if this was, instead of, if this was 45, okay, this was 1, okay, that's one way of using it. Another way of using it would have been, oh, someone giving something like this, right? And we had done it in both ways. Fine. So what happens in both cases? What's the difference here? If there are more statements after this, yeah, what is the difference? Here I get back the result. In this case, it's going to give me a result. In this case, error. Okay, fine. Both are nothing but invocations of a method, right? Okay, fine. So in this case, what has happened? In this case, what has happened? Has it returned? If return would have been executed, you would have got the result. Fine. So the operation finishes, and any method I'm referring to as operation, but it's about methods basically, or even some constructor, someone calling new and calling a constructor. Okay, an operation finishes successfully because of a return. Fine. The whole method is to execute. Fine. And ultimately come out with a success by giving a return. And what's the other thing which can happen? What's happening here? If return has not executed, then what has executed? Let's check that. Right? So what is executing in this case? Throw was executed. Fine. So yes, how do we throw? So yeah, okay. Now comes the thing here. So one option is a return. Okay. Another option to come out of a method, right? There are two options in the execution. It can use a throw statement. So we have a keyword called throw, but it has to be always followed by. It has to be followed by. What do we throw? An exception object. Not any kind of object can be thrown. And throw an exception object. Okay, fine. But what kind of exception object can it be? Okay, it has to match something in the throws list. Oh, we have a throws declaration for our method, right? See, here it has to match the return type. When we write a method, right, there is a part which is not about the body of the method, before the body of the method. What is mentioned in the before the body of the method?
Signature.
Yeah, what does a signature contain? Method is an operation. Right? Method is an operation. Parameter list is the inputs required by the operation. Return type is the type of result which you will get if it is successful. If it succeeds, that's the kind of result I'm going to get. And what is the throws? If you try this operation, you may get one of these kind of error conditions also. It's possible to have these kind of errors. Okay, so this operation succeeds, gives you this type of result. If it fails, or these are the failure type of failures which this operation can have. Okay, so throws is part of the declaration, just like return type is part of the method declaration. Okay, throws is also part of the method declaration. Clear? Fine. So even an abstract method may be mentioning a throws. Okay, even an abstract method may be mentioning a throws. Okay.
But it's the definition of what the throw be in the sub class of the abstract which overrides it.
I didn't get.
So an abstract method doesn't have right. So
can have a throws. Yeah, abstract method, though you may not have a body, right? When we write an abstract method, we mention return type or not. Okay, so same way, we can always mention the error conditions for this operation. Okay. I'll give a small example about the abstract method having throws clause. Okay, fine. Let's see that example. Fine. So consider. Okay. So you can consider a class called an abstract class. Yeah. Okay, so we have this abstract class called vehicle. Okay, fine. So we have something like this: public abstract. Okay, and what kind of methods can I be having? Oh, I would like to have a method. Okay, so we have this abstract method. Fine, because we can't put it in the vehicle. The subclasses of vehicle will be defining this operation. Maybe return type is void, but we have the method called run. Okay, fine. So vehicle is in a state, particular state, yes, and you have the run method, and you can have a throws for a breakdown exception. See, the idea is the run on a vehicle, any vehicle, can have a breakdown. And we say, oh, that's a breakdown exception. So an object of the type breakdown exception represents any kind of a breakdown which happens when a vehicle runs. You are only making a declaration. Okay, just like you are making a declaration that run method does not return any value. You are saying, oh, this run method is returning void, no return. Fine. Same way you declare. So when you write a method, fine, you just think about, oh, this is the kind of operation. Okay, this operation should be returning this value, and I expect that, oh, you might have these kind of error conditions. So that's a throws which you should have. Okay, when you design a method for your classes, yes, you think on those lines and not worry about the code which will be written in the body of the method. But the code which you write in the body of the method should not have an influence of what kind of throws you put. Your decision for throws has to come first.
In that case, can you have more than one?
Yes, you can. Yes. For example, now, okay. So let me also give it. Let's create a subclass of the class called vehicle, and we'll say, oh, we have the public and abstract class called car, which extends from, okay, and maybe it is still an abstract method, but let's see the method signature now. Okay, we have the void, the run method, it's being overridden. Let me put override here. Okay, but then it says it throws, and what does it throw? It says, yeah, it says out of. It has out of fill exception. It has a battery low exception. It has a puncture exception. Okay, so that's a list. So yes, you have a list of the type of error conditions. Okay, now there is a rule. Okay, fine. Now I'll have to mention a few more things here. Let me also give you another example of a method, fine, where an error occurs. We have used that method. We have just seen that method, but I'll show you. We have used the parsing method in the integer class. Now, if you look at that class, public class integer, okay, it looks like this. I'll only give the appropriate part from it. Okay, public class integer extends from it extends from the number class and implements comparable of integer. You know, this is having the comparable of integer, and here we have this method. Now I'm only looking at the header part for the. So we have this public method returns int. Okay, it's a static method as well. Yeah, public static int. Name of the method is parse int.
Yes.
Takes as parameter a string s and does not have a throws. Does not have a throws. Okay, fine. Some statements are there, and there is some place where it is doing a check Okay. Check string. Okay. Check string whether it has the appropriate characters, right? Fine. Check string if it contains invalid, check string if or okay, I'll say if string has invalid characters, okay, then throw says okay, new number format. And yeah, it's calling the constructor creating an object of the class called number format exception, which happens to be one of the subtypes under the throwable. Okay, this is one of the subtypes under the, it's a subclass, and some it's not a direct subclass, but some under some subclasses it's available as a, right? So later we'll see what is the class hierarchy, how the number format exception is coming. But what you observe here is there is a throw used in this method, but which is not mentioned in the throws clause. Yeah. Okay, fine. See, this here anyway, it's an abstract method, but when someone will be overriding this method in a subclass of the car, okay, he would be able to use a throw for one of these three types of things. Okay, so we do have a place where we mention throws for certain exceptions, and there are exceptions for which throws has not even been declared, but we are able to use this. We are able to use a throw even if the throws is not mentioned. Okay, fine. Okay, so we have two types of exceptions. Okay, we have got two types of exceptions, checked exceptions and unchecked. Okay, so we got checked and unchecked exceptions. And what's the difference? Throws is compulsory for checked exceptions. Throws is compulsory for checked exceptions. Right? Okay. We cannot have a statement. Okay, we cannot use a statement in a method which can result in a checked exceptions. Not mentioned in the throws. So for a method, it's like this. So in a state, fine, we cannot have any statement which can possibly result in a checked exception being thrown, okay, from a method. And so some kind of a checked exception which can be getting thrown, you cannot be using such a statement here. Okay, where it's a checked exception which may be getting thrown, but you have not mentioned the throws for it. So throws is compulsory for checked. Otherwise, the compiler will give an error. Okay, fine. So now when we understand about two kinds of exceptions, okay, so I mentioned two kinds of exceptions, checked and unchecked. Fine. How do we decide, how do we know, okay, which exceptions are checked and which are unchecked? Okay. And this is known from the class hierarchy. Okay, this is determined, fine. Okay, it's decided by the class hierarchy. Let's understand this now. Okay. Okay, so which are checked and which are unchecked? Let me go to the board and explain this now. Okay, there are a few more concepts we'll take up now. Okay, so as far as the exceptions are concerned, we understand that we have a super class for all kinds of exceptions, and that's a class called throwable. Okay, so we have a class called throwable. This is the super class for all kinds of exceptions. So exceptions are objects of this or any subclass of this. Okay, this has got two subclasses. Now these are all in the java.lang package. Okay. So we have this class called, there is one class called error. Okay, so one of the subclasses of throwable is the class called error. Another subclass of throwable is a class called exception. Yes, there is a class called exception as a subclass of throwable, and this has got a further subclass. Okay, of course there are a lot many other subclasses called runtime exception. This is I. Okay. So we have the classes called so this is the class hierarchy. As far as in the this is from the library. So as far as the library is concerned, throwable is one of the classes which has two subclasses. There are no other subclasses in the library for the throwable class. Okay, fine. There are subclasses of error. So let many subclasses exist under this. Okay, there are subclasses of exception which do not fall in the runtime exception, and there are subclasses of the runtime exception. Okay, oh, we had that number format exception which was happening. Oh, that's here. It's like this. Runtime exception has a subclass called, there is a subclass called the format exception. And this has a further subclass called the number format exception. Okay, so we have something like this. Okay, fine. See, what was important for us to know, where this, and this, these four classes, from the point of view of looking at the checked and unchecked. If you want to determine whether a particular exception type is a checked exception or an unchecked, we have to see where it falls in this class hierarchy. So all exceptions are checked except for error and its subtypes, error and anything under the error, as well as runtime exception and anything under the runtime exception. Fine. The objects of a error or any subclass of error is unchecked. Objects of runtime exception and any subclass of the runtime exception are unchecked. Rest of the things are checked. So if someone creates a subclass under the throwable directly, yeah, that's possible. Never advised. It's never advised to have a subclass under the throwable. But yes, it allows. Fine, someone may create it. Then it would be considered as a checked exception. Okay, if someone creates it under the exception but not under the runtime exception, okay, directly under the exception, subclassing directly under the exception, or maybe some subclass here. Fine. For example, we have that class called breakdown exception, and that's under the exception, let's say. So we define a class called breakdown exception by saying, it is the superclass here is the exception class. That means you are defining a class which is a checked exception. Your exception class is going to be a checked exception. If someone is creating a subclass under the runtime exception over here, then he is creating a unchecked exception. See, these are exceptions from the library. You will be creating your own exception classes as per your requirement. Fine. Someone going with this class called vehicle, yes, he will have to be defining the breakdown exception. I've used those class names like breakdown exception, fine, out of fuel exception. Okay, all such exceptions, they are nothing but they're not in the library. It's our own. Okay, you have your own package. We have the bank package, or we'll have some other exception classes over there also. Fine. So as per your application's requirement, right, you will have to find out which are the things, which kind of failures can occur in which kind of an operation, list them, fine, and create the subclasses, decide whether it should be checked or unchecked. Normally, we won't go for checked exceptions. Okay, when we define our classes, we normally go with checked exceptions. Okay? Okay. Fine, clear on this? What is checked and what is unchecked? Okay. Okay. Fine. Now, let's look at another aspect. So this part should be clear. Two keywords I have used so far. One is the keyword called throw, and other is the keyword called throws. What's the difference? Throws is a declaration, and throws is a declaration, and throw is a statement. And just like return is a statement, return type is a declaration, right? For a method, return is a statement, right? It executes return. Return type is just a declaration, right? So that controls what you put in the return statement. Same way, throws controls what can go in the throw statement. What can go in the throw statement? Something which is declared in the throws or an unchecked exception. You can be throwing an unchecked exception, right? Even if it's not mentioned in the throws declaration. Okay, fine. So we have exceptions like this, right? For example, this number format exception, that can be thrown. So parseInt method did not put a throws. Okay, the parseInt method did not have a throws because what it was throwing is a unchecked exception. It's not mandatory. Okay, one thing you remember here, it's not compulsory for throws to be there. But if you decide, if the parseInt, the one who developed the parseInt method, if he had decided to put a throws for the number format exception, it's still acceptable. It doesn't make a difference. It's not compulsory. Throws is not compulsory. It's not, it shouldn't be there. Okay. Fine. If someone puts a throws even for the unchecked exception, it's a good idea because the one who reads the method signature immediately knows what kind of errors can be there. Right? Fine. If it's a checked one, even if he has not read the things, the compiler will make him understand, oh, you are using something which can result in a checked exception. But you didn't mention a throws for it. So it's going to bring it out to the notice of the user of the method. You're using this, do you know this is happening? Yeah. You write a main method in which you are invoking a method which has a checked exception. Fine. It has a throws for the checked exception. And unless your main says throws for that same exception, it won't compile. Fine. Clear? So in what methods you are using, when you use a method, what kind of exceptions it might be having has an impact on the throws declaration. Okay, fine. So clear up to this point?
Yes, sir. Sir, one question is that, sir, can
Yeah.
I put the multiple exceptions there?
Where? In the throws?
Yes.
Yes, we can. Given that example, yeah, look at this again. Okay. Okay. So go back to that class car where even if we had a yeah, look at this abstract class car extends vehicle. Now this is this abstract method run throws, or what are the throws clause here? There are three of them. Fine, there are three of them, right? So we can say out of fuel exception, comma. So it's a comma separated list of exceptions. So throws followed by a list of exception types.
Okay.
Okay. Fine. And now it brings fine. Nice thing you did this. Reminded me about this. Okay. Now there's a rule about overriding method and the throws declaration. Fine. The rule about the overriding method of the throws declaration for an overriding method. Okay. Fine. An overriding method cannot have a throws for an for a checked exception which is not covered by the throws of the method being overridden. Fine. Something which is not coming under the fine. So you have a throws for example, here the list of throws here is not matching the list of throws in the method being overridden. Vehicle says throws breakdown exception, and this one says it throws. It doesn't say throws for breakdown exception, but just gives me some exceptions here. Okay. So is this fine? See, what does the rule say? The throws of an overriding method cannot have checked exceptions not covered by the throws of the method being overridden. The method being overridden says it throws a breakdown exception, whereas this one is giving me a different list. It's out of the list which is there in the method being overridden, but this is still fine because, okay, this would be fine provided these three classes are the subclass of breakdown exception. Okay, these are nothing but, so if they are the subclasses of breakdown exception, it's fine. Okay, you can't be including just any kind of thing here, right? For example, if someone says, okay, let me also include one more exception type. Okay, let me include in this comma IO exception. oh, that I have exception is a separate class and not falling under the breakdown exception. Okay, in such a case, oh, that's a compilation error. And this, you cannot be overriding. You in an overriding method, you cannot be increasing the throws which is there. Well, that says I can be throwing any kind of a breakdown exception. Right? When you're overriding in the car says, okay, I can have these kind of breakdown exceptions, but that cannot be more than what was for the vehicle. Okay, fine. But clear, it's something which has to be getting covered by the, so these three are already covered by the breakdown exception. And they are the subclasses. So we are assuming our class hierarchy to be something like this, right? We assume here the class hierarchy to be, we have the class called throwable, right? Having a subclass called exception, and under the exception we have a class called breakdown exception, and under this we have a subclass called, those three are the subclasses here. Okay, and okay, so in that case, yes, it's fine. If this is how the class hierarchy is, this is acceptable then, because breakdown exception happens to be the superclass for these three, and therefore this is not new thing. I'm not introducing a new throws. Okay, you cannot introduce a new kind of a checked exception in the throws, and that's what it says. Okay, when you override a method. And so rule about the overriding method in the throws clause. Okay, so throws for an overriding method, and there are restrictions. You cannot be introducing new kinds of checked exceptions over there. Okay, fine. So all this is fine, but we need to understand one more thing, okay, before we can. So yeah, but okay, we have to understand how the execution of a method like main takes place in the JVM. Okay, fine. We have to look at that aspect also. Okay, fine. What I'll do is I'll take it up. Fine, it's a new thing, so fine. Right in the beginning of the session, it's better to have. So I'll take it tomorrow. That's fine. That part, how the execution happens in a JVM. Fine. How the main method is getting executed. Fine. So various parts which are involved in that. So fine. What we'll do is we'll continue with this itself. Fine. So let's say, okay, what are the changes we want in our account class for this? Okay. Fine. Any questions related to the checked and the unchecked? Checked exception, unchecked exception.
We put throws and simple exception in the main class.
Yeah.
And then in the subclass, you can have all types of exceptions like null pointer or.
Okay. Now you're mentioning the null pointer exception.
Any type of
Unchecked exceptions, anything. Checked. If it's an overriding method that you're talking about. An overriding method cannot be introducing a new kind of a throws. Superclass, fine, where the method has been declared, it has a set of throws. Okay, it has declared that this method is going to, vehicle says that it can have these kind of errors if you have the run operation. Okay, no subclass can introduce another kind of an error over there in the throws, because someone who is interested in knowing vehicle V equals, and he says, I'm creating a new car, assigning to V. V dot run, what do we expect? What failure can we expect with V dot run? We'll look according to the vehicle class. Right? So if the subclass was introducing a new throws in that, fine. Someone thinking, oh, it will only have a breakdown exception. No, it is also having IO exception. And so that should not be happening. Clear? So new things cannot be introduced. What is not covered by the method being overridden. Subclass and throws for a overriding method and cannot introduce a new exception which is not covered by the throws of the method being overridden. Fine, clear on this? Okay, so we understand the keyword throw, we understand the keyword called throws, two things. Okay, fine. So can we update our application? And we can go for updating our application. So we will have to decide on some kind of a exception when someone gives a negative value. Fine. It's fine. We have a problem with the negative values, right? Okay. So what we can do here is something like this. Let's make the changes. Fine. One thing is, yes, we'll have to decide a class. Fine. For okay. So for negative value for the amount in our okay. So let us call this class. Okay, this exception class. Is and we'll call this as a negative amount exception. So how do we develop this and what should be the code for this? Okay, so we can have a public class called we'll keep it as part of the same package, and I'm just giving you the kind of code we may have called negative amount exception. Okay, and we so it doesn't become an exception just because of the name you have chosen. Okay, and you have to mention it as a subtype of the one of the. Okay, so we want it as a checked or unchecked. Okay, let's say we would like to have it as a checked exception.
Sir, so what is the difference to mention checked and unchecked exception? Is
Yeah.
there any?
Let's see. Yes. Okay. So we want it checked or unchecked. So accordingly, yes, we will decide the superclass. See, it's a class hierarchy, right? So if I say it is extending from, okay, if I say, okay, is it checked or unchecked? This is unchecked. Okay. Now it becomes checked. So that's the way you decide. Okay. So you are interested in having a checked exception. And our interest here is to have a checked exception called the negative amount exception. So we'll put it under the exception class. Okay, fine. Now coming now we'll have to look at the constructors of the throwable class. Okay, yeah, so we decide this, but yes, there are a few things we'll need to know, okay, before we can proceed further in this. So let's look at this class called throwable. Okay, let's have a look at the throwable class. Okay, the constructor. So if I look at the throwable class, okay, constructors, how do we create a throwable object? So it says you can create a throwable by, so there are these public constructors for throwable, where one is, yes, you can give, the most simplest form is you give some error message. So a throwable is capable of storing a error message. The default fine, the topmost class throwable, fine, says fine, I can have a, so if there is any kind of an error condition, yes, you will normally have a message associated with it. So yes, you have a provision for a message. Okay, you can create a throwable even without a message and without anything. So even this one is valid. Okay, this is a valid constructor. So you can just create a throwable without, so message remains null here. Okay, fine. There's another constructor for throwable where you can create a throwable by using another throwable, which we say is the cause of this exception. It's a cause of the exception. Okay, fine. So we have a thing called cause. Fine. Throwable can be created by using an existing some other throwable. Okay, fine. We even have a constructor which uses both of them. I think it's first the string and then the cause. So we have this and constructors like this. So these are the public constructors for the throwable class. These are the public constructors for the throwable class. Fine. So what is this thing called cause? Okay. Message is fine. I think it's understood that yes, a throwable, whenever a throwable is there, a message must be there. Right? Error condition is there. Okay. Have a message for it. Okay. Fine. But what is this thing called cause? Okay, and why does it come into picture? Fine. Cause is about exception chaining. We call it as chaining of exception. Fine. So we can chain the exceptions together. Okay, I'll try to give an example like this. Okay, fine. You know the example of day one. First day, what was the example? Florist example. Okay, let's understand exceptions from the point of view of the example of day one. Okay, let me bring that example again. JK Florist, yeah. Okay, so we had the JK Florist. Then let me go back here. Okay. Oh, yes. Here we had this, right? So if you look at it, it's something like this. What was that example? Oh, our problem was to send flowers to a friend who is in Kolkata, right? And so from Baroda, what we decided was, okay, we'll go to the JK florist, okay, and on JK florist we'll use a operation called send flowers. We'll say, okay, send flowers. That's an interaction. Operations are representing the interactions. So we can think about a class called florist having a method called send flowers. Fine. And it would take the parameters, the input required. Fine. This is what type of flowers you want to send, what's the name and address, and fine, what's the quantity of flowers. Okay, fine. So when you interact with the JK florist, you gave him the address, you gave him the uh, type of flowers and the quantity. Okay. What he did was he looked up into his diary, because it's not the same place, it's not a local address. Fine. He looks at the address, says it's not a local address, and therefore I should be contacting the KK florist who I know in Kolkata. So he then invokes a method on the KK florist object, again another florist object, and it has that method send flowers because it's a florist. Fine. And he again passes those parameters to the same parameters passed to the send flowers on KK florist. Right? And when KK florist receives those parameters, okay, he looks at the name and address, says it's a local address, and therefore he looks at the type of flowers. Okay, looking at the type of flowers, right, he contacts a flower producer, fine, uses the method called get flowers to get the flowers from a flower producer, and then invokes a method deliver on a delivery boy. Okay, we have the delivery boy, okay, on whom the KK florist has called the method deliver. Okay, fine. So now when KK florist looks at the name and address, not KK florist, when the delivery boy looks at the name and address, here's the flowers, here's the name and address, fine, he is going to that place. Okay, fine. If he finds your friend, then he will be taking the acknowledgement from your friend, fine, and returning an acknowledgement. He is returning the acknowledgement slip. But when he looks at that address, he goes to the street, the house number which is mentioned doesn't exist on that street. What will the delivery boy do? He cannot be returning an acknowledgement. Can he return an acknowledgement? No, it's not possible. So what will he do? He has a memo. And he pulls out a memo and puts a message, okay, invalid house number or whatever, right? He will put appropriate message and throw it to, the memos are thrown, acknowledgement is returned. Okay, and the two things are different, right? It's an error condition now, so he is going to throw the memo to whom? The KK florist, because you invoke the method, you get that. Okay, fine. So what is thrown? A memo. Memo is our throwable. And memos are thrown. Okay, acknowledgements are returned. Okay, so he is throwing the memo to the KK florist, right? And this memo, when KK florist gets a memo, what does he do? It's a failure of deliver. He invoked deliver and deliver has failed. What's the provision he has to do now if deliver fails? What will KK florist do? He has to throw the memo. It's a failure. I have to throw the memo. He has to throw the memo to whom? JK florist. The default behavior is the memo received from delivery boy is the one which is thrown from here also. That's a default behavior. It's getting thrown. So the one, see, the actual error, the actual cause was invalid address. That memo prepared by the delivery boy gets thrown to KK Florist. The same memo continues and gets thrown to the JK Florist, and that memo continues and it's thrown back to you. You invoke the method. You invoke the method send flowers on JK Florist. So you are receiving that same memo. Who prepared the memo? The delivery boy, he had prepared the memo, but that memo has been written in Bengali. Does it make sense to you? Is that going to be useful? No. So the mechanism is slightly different now. What's the mechanism? This delivery boy, when he prepares a memo and throws it to KK Florist, what KK Florist will do here is, he says, yes, I'm having an error condition, but I can't be giving this memo to him because he won't, to JK Florist. JK Florist may not understand this. Fine. So he prepares his memo in the way JK Florist can understand. He prepares a new memo. But with that memo, he attaches this memo. He wants to attach the memo as a proof. Right? So there is an error, but it has a cause. What's the cause? See, the memo prepared by KK Florist is also, it's a memo. That means it's a throwable. The throwable is prepared, but along with this throwable, I want to keep a new throwable, which is the cause. The memo prepared by the delivery boy is the cause for the memo which is being prepared by KK Florist. And KK Florist is communicating, throwing the memo to JK Florist. JK Florist receives the KK Florist memo, which has an attachment already. Okay, and he prepares his own memo to give it to you. But with that, he's attaching the thing received from KK Florist. So you can see all the three memos. What you receive will be, you receive only one memo, right? That's a memo from JK Florist. But JK Florist prepared the memo, but along with that, he attached the earlier memo. And so that's the exception chaining, chain of memos and chain of throwable objects. Okay, fine. So the reason for the cause here, right? Cause, oh, that's the actual cause, root cause. The original one, which was prepared by the delivery boy, that's the root cause. We call it as the root cause. The exception is, which comes to me, is the one from JK Florist. But that's not the original one. Fine. So from that, I should be able to access the earlier one, saying, okay, what is the cause of this? If the cause is null, then that's a root cause. If there is a cause available, fine, then I'll examine that cause and see if it has another cause already. Okay, so you can keep on traversing an exception by looking at its cause. Okay, so cause will again be another exception basically. Right? Clear why we have the cause? Okay. Okay, so let's get back to this now. Okay, fine. So the constructor here, right? So now if we look at the methods, okay, fine. What kind of methods can be there? So we have a public method, okay. Return string, name of the method is get message. And that's understandable, right? Okay, public, sorry. We have the method to return throwable. Okay, and there's a method called get cause. Okay, one more thing, actually these things, these two things, right? They were introduced from Java 1.4. Right? I mean, they're not there originally from the initial version of Java because they are introductions at a later stage. Okay, and someone wants to use them and in the earlier code to update them and wants to update them to start using the cause. So someone else might have created the object, but now I would like to set up the cause value, right? So we have the getter method for message and cause. There's no set method for the message. You can't change the message. Okay, no one can, once a throwable is created with a message, that message cannot be changed. But we have a method returns void, name of the method is init cause. There's no set cause. It's different from saying set cause. Okay, normally a set method means change the value. It's not about changing the value. It's about initializing it. What's the difference between this initialization and set? Init and set, what's the difference? If someone, just a convention here, right? A set method means I allow him to change the cause. Init method here says this method would change the cause which is available in this throwable provided it is null. It's not already set, then it can be set with this. If it's already set and you try to do this, it's an error. Okay, so init cause works on those throwable where cause has not been set. Okay, fine. So it's only in such case. Fine? So it's not about changing the cause. Fine? So change is not allowed, right? Message cannot be changed, cause cannot be changed. Okay, fine. There are a few other methods. I'm mentioning them. But yes, to understand this better, we will have to look at the way execution happens. Right? So I'll just mention this method. We have a method. There's a method called print stack trace. We have to understand what is a stack trace. Okay. There are a couple of methods more which I'll mention. There's a, okay, I might mention this method. Okay. Fill in stack trace. Okay, and print stack trace, or even before this I might put the other method which is about, there's a class called stack trace element again in the java.lang package. An array of those is returned when someone uses a method called get stack trace. Okay, and this one is simply about printing that stack trace. Okay, so when a throwable is created, a throwable object contains three things. A throwable object is containing three things possibly. One is a message, other is the cause, and these two we understand, right? Third one is the stack trace. Right? The stack trace is basically a snapshot of the runtime stack at the time the throwable object has been created. It's a snapshot, a picture of the runtime stack, okay, where the execution is happening. We'll have to understand how the execution happens to understand the stack trace better. Okay, and once we know that, yes, so these three, yes, we'll have more explanations tomorrow. Okay, and at this moment, yes, we'll have to leave it. Okay, but I've just listed those three methods, and there, this one is for actually setting up the, this is for taking the snapshot. I was saying, okay, take the snapshot of the runtime stack. So this one takes the snapshot of the runtime stack, and this one takes, shows you what is the snapshot it has taken. Okay, what is the snapshot it has taken. So stack trace here is the snapshot of the runtime stack. Think in that manner, that stack trace, whenever someone says stack trace, it's a snapshot of the runtime stack. What's going in the runtime stack at the execution time, we'll be looking at it tomorrow. Okay, fine. So get stack trace is giving us so that we can examine what was the picture taken at the runtime stack. Fine. And print stack trace is simply, yes, print out the stack trace. Fine. A dump of what was the picture taken at the. So a throwable object always has this. See one thing, this method is called from the constructor. Okay, fine. This is okay, it's called from constructor. So whenever you create an object of any subclass of throwable, you know, superclass constructor is always called. So whatever the subclass may be, these methods are there for you, and the constructor here is taking a snapshot. So any constructor you write, it will have the snapshot. Any throwable object always has a snapshot. One snapshot taken at the time of creating the object. That's what it is initialized with, but since it's a public method, later someone who has a throwable object, right, can always ask it to replace it with a new runtime stack picture. Fill in stack trace can be called any time. So whenever it calls a fill in stack trace, the picture it had taken about the runtime stack gets replaced with whatever currently is found there. Okay. Okay, so fine, these are the methods we have. Okay, fine. Okay, now if we go back to that negative mount exception class, yeah, what we might do is, it's an error condition. Now, see, we wanted to look into that so that, see, okay, whatever I have mentioned for throwable, exactly same thing, same constructors are available for the subclasses, 3 subclasses, error class, exception class, and the runtime exception class. All these 3 inherit the same, have the same constructors. I don't say inherit, constructor is not inherited, but they have exactly same constructors. So in the constructor list for the error, exception, and runtime exception, yes, you will find these 4 public constructors. Okay, so when designing a subclass, okay, so when I'm designing a subclass of the any of those exceptions, right, and here I'm extending from exception, I know now the constructor of superclass. Okay, fine. So if a negative mount exception occurs, what you might like to keep with this, it can say, let me have a amount which is the negative mount value. Right? What is the negative mount value which has caused the error? Right? Okay, it's a part of the error condition. I'll keep the negative mount value. And if you look at the constructor here, okay, what can be given as a parameter? A string for the message, as well as a long for what's the negative amount value. Okay, and how do we use it? Super with the message. Right? Why we needed to know the constructors of the superclass? Right? Okay, and then we can just say this dot amount is equal to AMT. Okay, and provide the, see, the method to get the message is already inherited. Provide the additional method to return the amount, get amount. this can just simply say return this dot amount. Fine. Fine. We'll look at the toString method also, how it has been ported, and we might like to override it here. At the rate override public string toString. Okay. So we can say return super.toString. Okay, plus let me add a colon plus this dot amount. So whatever is being done in the toString of the super class, that should take care of the message part. Okay, it's already taking care of the message part and the name of the class basically. Okay, so to that I'm just saying, okay, also add this information about the message, because I have this message amount also. Right? So yeah, that's a way you might be. So our first thing would be here. The first change would be in this place. Another change which may come, okay, is related to the when this is the place, actual place where the things, this class will have to be used now. Okay, how we want to use this class. I'll just give an example here. For example, yes, we have this public method. Okay, so it's going to come even in the constructor, right? So we have the public method returns void, name of the method is deposit, parameter is amount, and we'll say throws. So if you try to deposit, fine, be aware you may get a negative mode exception. And what's the first thing you do? If amount is less than 0, then what? We want to use the other keyword, throw new and what's a parameter? We'll have a message. Okay. And what's the amount? That's amount. Empty. Fine, whatever amount was given, it's negative, and therefore I'm passing it as a parameter in the constructor here. Okay, so that's the thing which will be different here. Okay, then you continue it whatever you are doing. So first do a check, negative, I don't proceed. This has to fail. Fine, so wherever we fail, we do something like this. That's the whole idea of a method, right? And same thing, even a constructor will have a throws. Just like method have a throws, constructor also can have a throws. In the constructor for account, if someone gives me a negative opening balance, throw this. Okay? Okay, so any questions? Yeah? Fine, so see, it's mainly about what we have seen today. Throwable represents all kinds of error conditions. Subclasses of throwable, we have two kinds of exceptions, checked and unchecked, and the class hierarchy decides which is checked and which is unchecked. Right? All exceptions are checked except for error and subclasses of error, exception, runtime exception and the subclasses of runtime exception. Those two are unchecked. Everything else is checked. Okay, if it's under these two things, unchecked. Otherwise, checked. Okay, what's the difference? We have the declaration part, which is throws. Throws is for the declaration, and throw is a statement. Okay, fine. Throws is compulsory for the checked exceptions. Throws may even mention unchecked if you want, right? Will not make a difference whether you mention or not. Okay, fine. And then yes, we saw about the constructors for the throwable class. Some method need explanation. Okay, especially the stack trace thing. Okay, we haven't yet gone into what is a stack trace here. Okay, but to understand that, yes, we'll have to look at how the execution happens at runtime in Java. Okay, fine, we'll see with the execution of a main method. Fine, how the main method executes. Okay, fine. Okay, fine. So, fine. Anyone has questions still? Okay, then we continue tomorrow. Tomorrow is Friday. Oh, Saturday. We'll continue on Monday now, right?